Hey fellas, welcome to my video series on solving all of the LeetCode problems, starting with the easy ones all the way to the hard ones. Now we're going to the same tree. What is this? Okay, another tree thing. Given the roots of two binary trees, P and Q, write a function to check if they are the same or not. Two binary trees are considered the same if they are structurally identical and the nodes have the same value. Okay, so this is the same. This is not the same because this is a left child, this is a right child. Okay, so what we can do here, hmm, so what we can do, this is kind of like a continuation of the previous problem where we write the like a array of integers representation of a tree, and it's pretty much the same if both representations are the same, then we can say that it's the same binary tree. So let's go. So how can we do this? So the best way to do is let's do it iteratively. So stack one is P. And what I'm going to do is while stack one current, I'm just going to copy it from the previous one, guys. Just check out the video on this. So I'm just going to copy it. That's what programmers do. They copy and paste things. So is same tree. The only difference here is, please watch the previous video, is that I'm not appending the nuns, and here I want to append the nuns. Yeah, so I think if I do this, then stack one is self dot in order traversal of P. I don't want to do stack one, just free representation of one, and same thing here. Representation of Q, and return X. Yeah. Okay, I wonder why this happened. P11. I have no idea why. This shouldn't be the same. Guess I'll have to copy all of this into my PS Code and run the debugger. So, and make directory same tree. code under same tree. Solution.py. Now we need to do solution of is same tree, and now we need to do this, which sucks. Tree node of and look at 1 1 1 tree node of 1. So it's val left right. Yep. And this is the first tree. And then it's tree node of 1 no. I think it's this. Like this. None, 1, none, 1, none. I did none, 1, none, 1. So it depends the right, the left, the right, the left. The right, the val, and then the left. And if we look at here, it's 1 and 1. Let me see if the test case looks at it, draws it. P and Q. So it should be one is to the left, one is to the right. So they are not the same. So the root is I have something to the left. So my current value is that, and my stack is empty. Then I add the right, which is none, my val, and then my left, which is something. Okay, so none, something, okay. And now this should be a none. Is it? What's popping from the end is popping the left one first. Okay, that's okay. And it's none, none, 1. So none, 1, none, and then none. That makes sense. Okay, I think I know what I can do here. Okay. So the situation here, I believe, is that they coincidentally are the same because I'm adding none values when they shouldn't be added. I should only add non-values on the right. No, I shouldn't even add them. I should only add non-values to the left if there's one to the right. So if CV right, stack append CV val, okay. If CV right, if CV left, we add it. Or CV right. Because if the right exists, then the left also must exist. Should we add this one, the root one, if it's a none? Maybe it doesn't make a difference. Yeah, 1, 1. None, 1, 1. I want it to be none, 1, 1. I want it to be 1, none, 1. I guess it's fine. So, the root has a value. So why is this 1, none, 1? Tree node if CV writes. It has something. Oh yeah, it does have something. Yeah. Stack is the right one, the middle one, and then none. CV, this is the right one now. Now I'm stacking. Okay, let's try this. Almost. This was working. This was creating the right representation. I'm just going to do the same thing again. No difference. Submit. Oh, right, because the previous one was the problem here is it's not this one. 60 is test case. Output true, it should be false. Why? Visualize it. 5.4. Oh, this is like switched up. So yeah, of course it's not the same. Why would it be the same? It's the same tree node 1. That's tree node 1, tree node 2. 2, tree node 1. This is a good example. This is the same tree, but the opposite branches. 1, 1, 2, 2, 1, 1. If I did it differently, I would add the result immediately because I know it starts with a root. So res dot append val. Well, cv dot val. So it adds immediately. So if type cv is different than int cv, if cv writes, we append it. Append cv val. Now we don't need this. If cv left or cv right, let's see what happens if we run this. 1, 1, 2, and now this is 1, 2, 1. Yeah, yeah. cv. If cv is none, res dot append none. Else Yeah, because it's important to append the none. Okay, worked. Yeah, so what I did was we start with the root and I just save the value of the root, then we append the right one and we append the left one. And then we go over the right one first and I just save the value. So I save it in this order and this order seems to work. So hope you guys enjoyed it.